Okay, so this video is going to be about related rates from chapter 2.6. Okay, so here are some basic steps to follow when solving related rates problems. Step 1 would be to identify the givens and your unknowns, and then to sketch and label a picture. Step 2 is to write an equation involving both the given and unknown variables. Step 3, implicitly differentiate both sides of the equation with respect to time t. That's very important. And then lastly, substitute in your known values and then solve. Okay, so for this question, at night a 6-foot-tall man is walking away from a 20-foot-tall streetlight at 2 feet per second. How fast is the tip of the shadow moving, and how fast is the length of the shadow changing? So, okay, we basically have two questions that we need to answer here. So let's call this first question A, and the second question will be called B. So let's solve for A first. Okay, so the first step in solving related rates is to draw the picture. So let's draw a picture. And let's call this is going to be the street light. So it said that the street light is 20 feet tall. And this street light is shining light down this way. So if the man is standing right here, he's 6 feet tall, then there will be a shadow right here because the light will be hitting his head and it'll be dark down here. So this will be a shadow. And this is the tip of the shadow right here, that dot. So we know that, okay, let's write our givens. Dx dt is 2 feet per second. And let's call this x, this distance. And then let's write the x equals the distance from the base of the street light to the man. And then let's call this distance y. And then y is distance from base of streetlight to the tip of the shadow. Okay, and we're looking for dy over dx. That's our unknown. Sorry, dy over dt. That's our unknown. So we found our givens and unknowns, and now we just need to find an equation to relate them all. And we can see that these are similar triangles. So if we called this, let's call this point A, B, and C, and then D, and then E. Those will be those points. So we can say that triangle ABC is similar to triangle DEC. So okay, so we can say that 20 over 6 is equal to y over y minus x, because 6 over 20 is equal to y, and then this part is the shadow. If this is y and this is x, this is y minus x. So 20 over 6 equals y over x, and we can cross multiply. So 20y minus 20x equals 6y, and then 14y equals 20x, and then solve for y. Y equals 10x over 7. Alright, so now we have our givens, our unknown, and now we have our equation. So now we can implicitly differentiate both sides. I'm going to go back up here. So let's see. So d over dt equals d over dt, and 10x over 7. So dy over dt is equal to dx over dt times 10 over 7. And now we can substitute in. So we have dy over dt equals dx dt is equal to 2 feet per second. So 2 times 10 over 7. And this is an ugly number. Dy over dt is equal to 20 over 7 feet per second. So back up to what were we answering? How fast is the tip of the shadow changing? It's changing at 20 over 7 feet per second. So that was the answer to the first question. Now we have how fast is the length of the shadow changing? So this is the length of the shadow right here, this dark spot. Let's rename this L for the length. So let's go down. Okay, this is letter B. So we already said that L can equal y minus x, right? Because y minus x is this length right here. So L equals y over x. L equals y minus x. So let's implicitly differentiate both sides. So d over dt times L, d over dt, y minus x. So dl over dt is equal to dy over dt minus dx over dt. Now we just solved for dy over dt here, and we were given dx over dt up here. So all we have to do is plug in dl over dt. Sorry, you can't see that. dl over dt is equal to 20 over 7 minus, and then dx over dt was 2. Dx over dt was 2 feet per second. So we can write 14 over 7. So that means that dl over dt is equal to 6 over 7 feet per second. So how fast is the length of the shadow changing? 6 over 7 feet per second. And that's the end of this video. Thanks for watching.